Hello again. In this problem, we will be doing a related rates problem. So a child flies a kite at 80 feet. The wind carries the kite horizontally at 34 feet per second. How fast should the child let the string out when the kite is 170 feet away? So I already drew a really good picture here, as you can tell. And so you'll see that we kind of have a triangle here between the kite, the ground, and the child. And we know that the child is flying the kite at about 80 feet. And that's going to be remaining constant throughout the problem. You'll notice that the child also has some height, but we're kind of neglecting that. So, as the kite is flying horizontally, of course, we know that the hypotenuse will be changing. So we're going to express that as a variable. That's the most important thing in these related rates problems, is to figure out which values are constant and which ones are changing. And the changing ones we want to express as a variable. Of course, this horizontal distance is changing as well because it's going away at 34 feet per second. So we'll go ahead and call this A. All right. So let's go ahead, and before we even express anything in an equation, let's write down what we know. I already took care of this 80 feet piece of information. Then we have that the horizontal is changing at 34 feet per second. We know A is our horizontal value. And since it's changing, we can express that its derivative, dA dt, the change in A over time, is equal to 34. Sometimes you'll get something like the distance is decreasing at 34 feet per second, in which case we can put a negative in front. And then we know that we want to figure something out when the kite is 170 feet away. Notice that the distance between the child and the kite is this c value. So we want to figure out this value when c is equal to 170. And what are we trying to figure out? We're trying to figure out how fast the child should let the string out. The string is also the c value, and since it's asking how fast, we're going to be trying to solve for dc dt, the change in c, or the change in the string's length over time. So that's ultimately what we're trying to find out. Okay, so those are the pieces of information that we know and that we're trying to find out. So let's go ahead and start by expressing all of our values in terms of an equation. And the easiest equation we can think of with a triangle is, of course, the Pythagorean theorem. So a squared plus 80 squared would equal c squared. And unlike in optimization problems, we don't have to solve for a or c. We can just go ahead and take the derivative right away. And here, things might be a little bit confusing if you don't understand implicit differentiation. If you don't understand that, go ahead and take a look back at that section, and then what I'm doing here will make a little bit more sense. But essentially, what I want to do is take the derivative of this whole equation with respect to t. So both sides of it. So when I take the derivative of a squared, I would get 2a. And then since I'm taking the derivative with respect to t, I would have to multiply by dA dt. Remember, an implicit differentiation, whenever we take the derivative of a certain variable, we have to multiply by the derivative of that variable. Of course, the derivative of 80 squared would be 0. And the derivative of c squared, similarly to before, would be 2c times dc dt. this time times dc dt, since we took the derivative of a c value. All right. Scrolling down here a little bit. Now what I'm going to do is I'm just going to go ahead and plug in the pieces of information that I know. So I know that dA dt is equal to 34. I know that c is equal to 170. And of course, I want to figure out dc dt, so I can leave that as a variable. But here, you'll notice that we have two variables and only a single equation. We want to figure out what dc dt is, but we don't yet know what a is. So let's try to figure out what this a value is. So to do that, let's again make use of the fact that c is equal to 170. If c is equal to 170 at this point, then we can also figure out what a, the horizontal distance, is at this point, again by using the Pythagorean theorem. And we'll do that up here. So a squared plus 80 squared equals 170 squared. And if we solve this equation out, we'll get that a is equal to 150. Now we can go ahead and plug that in down here in order to help us solve dc dt. Okay, so we get 2 times 150 times 34 equals 340 times dc dt. And if we do those multiplications and divisions, we will get that dc dt is equal to 30 feet per second. So to put that in perspective, when the wind is carrying the kite horizontally at 34 feet per second, the child will need to let the kite out at 30 feet per second in order to keep that kite's height at 80 feet.